In this video we are going to discuss about the Z transform and its basic fundamental definitions and few problems. The Z transform is a mathematical tool that converts discrete time signals sequence of numbers into a complex frequency domain representations. It acts as the discrete time equivalent of the Laplace transform, mapping signals from the time domain n to the complex Z domain. Mathematically, you can write the Z transform x of z is equals to sum where n varies from minus infinity to infinity x of n z raised to the power minus n. It can also be said that the analysis of discrete time LTI systems to Z transform. So like we have studied three transform: Fourier transform, Laplace transform, and this one is the Z transform. All these transforms are used to analyze the signal in the frequency domain. But the basic differences between these transforms are like Fourier transform is used to convert the time domain signal into the frequency domain signal. But we have seen that the Fourier transform there is only imaginary number, like we have seen e raised to power j omega. So there is no real number. But for the Laplace transform is again used to convert the time domain signal into the frequency domain signal, but we use S domain, like S plane, where we have real as well as the imaginary signal. Like where we cannot use the Fourier transform, we use Laplace transform for the continuous time signal, as well as if we have real and the imaginary part of the signal. But for the Z transform, as we seen that we are basically convert the discrete time signal into the complex frequency domain representation. Like the last two transform, Laplace and the Fourier transform, they are used for the continuous time signal, but the Z transform is used for the discrete time signals. But all these transforms are used to analyze the signal in the frequency domain. Fundamental differences between continuous and discrete. So if it is a continuous, so time is continuous, and if it is a discrete, then the time is discrete. Continuous signal can be defined for all values of time. Discrete signals are defined only at discrete times. Independent variable is time in continuous time signal, but for the discrete time, the independent variable is time n. Graphically representation, we can see this waveform, a continuous in time, we can represent the continuous time signal, but for the discrete time signal you can see there are different number of samples n at a different n samples, like we have different values of the sample at different n locations where we have different samples. The Z transform of a discrete time signal x of n is represented by x of n in term of Z transform, that is x of z. So like this is a discrete time signal and x of z is a Z transform, which is the signal in frequency domain. And we can write x of z using this mathematical equation. X of z is equals to sum where n varies from minus infinity to infinity, x of n z raised to power minus n, where x of t is the frequency domain and f of t is the Fourier transform or the Laplace transform. Like if the signal in time domain is continuous, then we can use the Fourier transform or the Laplace transform. But if the signal x of n is a discrete time signal, then we can use discrete Fourier transform or we can use Z transform. And for the Fourier transform, we know what is the formula. So that is Fourier transform of x is equals to the integral where the limits varies from minus infinity to infinity x of t e raised to power minus j omega t dt. And similarly for the discrete time signal, we can write the Fourier transform. But if the signal is a discrete time signal, then we can represent the Fourier transform, or you can say Z transform or discrete Fourier transform with the symbol summation, like you are replacing the integral with the summation sign, where n varies from minus infinity to infinity, x of n e raised to power j omega whole power minus n. Like here in place of z, you can write e raised to power j omega. So the formula for the Z transform, x of z is equals to summation where n varies from minus infinity to infinity, x of n z raised to power minus n, and we replace z with r e raised to power j omega. R is the amplitude, if there is an amplitude. So we just replace that z with this value, like x of z is equals to summation, where n varies from minus infinity to infinity, x of n r e raised to power j omega whole power minus n. So you can replace the value of z here. You can write r e raised to power j omega whole power minus n. And then you can again rewrite this r with the separate power, like here you can write r raised to power minus n and e raised to power j omega power minus n. And we know that the discrete Fourier transform of x of n is equals to sum where n varies from minus infinity to infinity, e raised to power n, sum where n varies from minus infinity to infinity, x of n e raised to power j omega n. So we can rewrite this format using this formula, like that can be equals to discrete Fourier transform x of n. So because this r raised to power minus n is additional, so you cannot see this r raised to power minus n in this formula. So you are basically writing this additional value as it is, like discrete Fourier transform x of n multiplied by r raised to power minus n. So the Fourier transform of x n r raised to power minus n is equals to x of z, because that is the Fourier transform of x. And in place of z you can rewrite again r e raised to power j omega and so on. You can take this Fourier transform on the other side and that will become inverse Fourier transform. So you can write x n r raised to power minus n is equals to inverse Fourier transform x or e raised to power j omega. And if this is the r raised to power minus n, if you take that on the other side, it will become 1 divided by r raised to power minus n. And you know the inverse Fourier transform, you know the formula of the inverse Fourier transform, that is equals to 1 over 2 pi integral where the limit varies from minus infinity to infinity, x or e raised to power j omega, e raised to power j omega n d omega. So you can take this Rn inside, and if it goes upward, the power from minus n changes to positive n. So you can rewrite that formula using this equation, 1 over 2 pi integral the limit from minus infinity to infinity, x or e raised to power j omega, and that Rn becomes the power here or e raised to power j omega power n. So you can rewrite this equation in this format. So we know that z is equals to r e raised to power j omega. We have already used this equation. So if you differentiate this on both sides, you can write dz is equals to r, because r is a constant, so it will be in front, and you know e raised to power j omega, and you are differentiating with respect to omega, so that is why j is written in front of e, or j e raised to power j omega d omega. So that can be equals to j or e raised to power j omega d omega, and you know that or e raised to power j omega is equals to z. So you can rewrite as j z d omega is equals to dz, or if you want to see what is the value of d omega, you can rewrite d omega is equals to, so that will be on the other side and it will be divided in term of d omega. So the d omega will be equals to 1 over j z dz. So you can use this value in previous equation, and you can rewrite x of n is equals to 1 over 2 pi integral where the limit varies from minus infinity to infinity, x of e or e raised to power j omega. In place of or e raised to power j omega, you can write z, and here again you can write z power n, and then in place of dw you can write 1 over jz dz. And you can, because this is a constant, you can take outward, so the 1 over 2 pi j, but this is the power of z is positive. If you take upward, its power become negative, so you can rewrite, because the bases are same, so the power will be added, like you can write z n minus 1 dz. Now we can solve few problems in order to have a more understanding of the z transform. So the problem is that a finite sequence x of n is defined as x of n is equals to 5, 3, minus 3, 0, 4, minus 2. So these are basically the discrete time samples, and you are asked to calculate x of z. So we can rewrite these samples in this format like x of n 5, 3, minus 3, 0, 4 and minus 2. So if you see in these samples, so there's a no arrow given, like here if no any arrow given, then we can put the arrow here and we can say that okay, this is will be our first sample. But if there is an arrow given, then we can say that okay, that will be our first sample. If no arrow is given, so we will insert the arrow on the first sample and we can say okay, that will be our first sample where the value of n is equals to 0. So x is 0, so the 5, and x1 is 3, x2 is minus 3, x3 is 0, x4 is 4, x5 is minus 2. So we know that what is the z transform of x of n, that is equals to x of z, where the summation whose limits varies from minus infinity to infinity, x of n z power minus n. So we can see these samples are given and we can use these values here in these equations. So how many samples? From 0 to 5. So it means that, so this lower limit changes from 0 and the upper limit is 5. So x of n z power minus n. So we start writing the values. So if it is x of 0, we know what is the value of x of 0. X of 0, so z power minus 0, so that will be equals to 0, and then plus x of 1 z power minus 1 plus x of 2 z power minus 2 plus x of 3 z power minus 3 plus x of 4 z power minus 4 plus x of 5 z power minus 5. So we know what is the value of first sample where x is equals to 0, because if the power is 0, then it will be equals to 1. So the value of the first sample was 5, so that is why it is written. Second sample is 3 z power minus 1. Third sample 3, it will be minus 3, so that is why minus 3. So you can't see any the value of this sample was equals to 0. So the value of that sample was equals to 4, the value of that sample was equals to minus 2. And then you can rewrite this equation as it is, like x of z is equals to 5 plus 3z minus 1 minus 3z minus 2 plus 4z minus 4 minus 2z minus 5. So that is the z transform of the given question. The second question is that a finite sequence x of n is defined as x of n is equals to 5, 3, 0, 1, 2, 4. And you need to calculate what is the value of x of z. So from this sample you can see that arrow is given. So arrow, where the arrow is basically given, it is given at value 1. So it means that this will be your first sample where n is equals to 0. So you can rewrite that samples again, so in term of x values of x of n. So if this is x of n, on the right side the positive samples and on the left side you have negative samples, like x of 0, x of 1, x of 2, and x of minus 1, x of minus 2, and x of minus 3. So you can use again the z transform formula, same formula, and you can see the lower limit. Now you have minus 3 and the upper limit you have 2. So you can use these limits here in this question and you can easily solve that what are the values here. So you can see, so the x of minus 3 z plus 3, because minus minus positive, plus x of minus 2 z minus minus positive 2, x of minus 1 z 1 plus x of 0 z 0 plus x of 1 z minus 1 and x of 2 z minus 2. So you are basically just inserting the values of the samples at this particular location and you are basically ending up the solutions. X of z is equals to 5z3 plus 3z square plus 1 plus 2z minus 1 plus 4z minus 2. So then there is another question that find the inverse z transform of x of z is equals to 4z4 minus z3 minus 3z plus 4z minus 1 plus 3z minus 2. So you know the z inverse transform is equals to 1 over 2 pi j integral whose limit varies from minus infinity to infinity x of z raised to power n minus 1 dz. and you can expand that like in this format. So 4z4 minus 1z3 plus 0z2, because from this equation you can't see any value of z square, so that is why you are writing 0 here. And then minus 3z1 plus, again you don't have any values of z0, so that is why you can write 0 z0 plus 4 z minus 1 plus 3z minus 2. So you can rewrite in the form of samples, like this is this sample at n is equals to minus 4, so that one at n is equal to minus 3, and this one is n is equal to minus 2 and minus 1, and then 0, then 1, and then 2. So you can use x of z, so that is equals to these values here. So like this is basically the formula for the z transform, but you need to calculate what is the inverse z transform. So basically using this formula you can write x of z is equals to 4 minus 1 0 minus 3 0 4 and then 3. So this arrow shows that this is the value where x of n is equals to 0. So this is a quiz. You can solve yourself and let me know what is the answer. Like you need to calculate, find the inverse z transform of x of z is equals to 2z square plus 3. The second question is x of z is equals to 3 plus 2z minus 1 plus 3z minus 3.